Welcome to Mathema-six Number System. This is the second part of a two-part video. And the greatest common factor is, drumroll please. What is the greatest common factor? Let's take a look. The greatest common factor of two or more integers, of which at least one is not zero, is the largest positive integer that divides the numbers without a remainder. Let's take a look at an example. The greatest common factor of 24 and 16 is 8. This is because 24 is divisible by 8 and 16 is divisible by 8. That's what a factor is. What other numbers are factors of 24 and 16 but aren't the greatest common factor? 2 and 4 are factors of 24 and 16, but 8 is larger, and we're looking for the greatest common factor. How can you find the greatest common factor? Find the factors of each number and look for overlapping factors. For example, 24 equals 2 times 2 times 2 times 3. 16 equals 2 times 2 times 2 times 2. The overlapping factors are 2 times 2 times 2, which equals 8. And that's how we got 8 as our greatest common factor. What is the least common multiple? What is the difference between the least common multiple and the greatest common factor? Good questions. The least common multiple of two integers a and b is the smallest positive integer that is divisible by both a and b. If either a or b is 0, the least common multiple is defined as 0. What is the least common multiple of 4 and 6? Find the multiples of each number and compare the results. You don't have to find all the multiples, that would take you out to infinity, but just list out several until you find multiples in each. So the multiples of 4 are 4, 8, 12, 16, 20, 24, and so on. Multiples of 6 are 6, 12, 18, 24, and so on. The multiples on both lists are 12 and 24. Since 12 is the lower number, it is the least common multiple of 4 and 6. So what is the difference between the greatest common factor and the least common multiple? The greatest common factor is a number that divides into two whole numbers, as 8 was the GCF for 16 and 24, so it's a factor. The least common multiple is the number that the two whole numbers divide into, as 12 was for 4 and 6, so we're looking for multiples. The rational number system is often shown on a number line. There are many ways to represent a number line, and we're going to take a look at a few. Rational numbers can be positive or negative. We deal with positive numbers every day. Time, weight, and height, for example. Some of the numbers we live with can be positive or negative, such as temperature. Take a look at a thermometer. It has positive degrees, 0 degree, and negative degrees. 0 acts as a center point having a 0 value. You can think of 0 as nothing or empty. 0 is considered to be an even number. It is the smallest non-negative integer. It is a whole number and therefore a rational number. There isn't universal agreement on whether or not 0 is a natural number. It is one of the most interesting numbers in mathematics. Can you see that positive 20 degrees and negative 20 degrees are the same distance from 0? What happens if you remove the positive and negative signs? They are the same number, 20. What do you think negative 20 means? Not 20. The two negatives equal a positive, so negative 20 equals 20. Is there a negative 0? 0 is its own negative. The number line can be extended to coordinate axes, also called a Cartesian plane. At the top we have a rational number line. Fractions belong on a rational number line as well, but they just aren't shown here. the bottom we have rational numbers on coordinate axes. That is the x-axis and the y-axis. The coordinate axes is plural, axis is singular. Let's take a look at the coordinate axes. Things you should notice. The ordered pair of 5, 5 and the other ordered pair, -5, -5, differ in sign. The second ordered pair numbers are negative. The two ordered pairs are in different quadrants. If you draw a line from the ordered pair with positive numbers to the ordered pair with negative numbers, the line transects or passes through the 0, 0 point. What happens if the ordered pairs have mixed signs such as 5, -5 and 5, 5? Notice that the line drawn between the points represents distance or length. Here is another example of ordered pairs on the coordinate axes. The ordered pair 10, 10 and the ordered pair -10, 10 have different x-axis values. The two ordered pairs are in different quadrants. If you draw a line between the two ordered pairs, the line transects or passes through the y-axis. Notice that the line drawn between the points represents distance or length. The distance from each point to each axis is the same, y. Finally, let's look at an example of ordered pairs where the points are in the same quadrant. The sign for the x-axis coordinate for each ordered pair is positive. The sign for the y-axis coordinate for each ordered pair is negative. What happens if you connect the 2 points? Does the line transect the x-axis or the y-axis? Why? We have examined points on the rational number line and ordered pairs on the coordinate axes. Now let's look at absolute value and the number line. What does the absolute value of a number have to do with its position on the number line? Good question. First of all, let's examine ordering on the number line. Note that going from left to right, the numbers get larger. -1 is bigger than -4. Think about that. It's a bit counterintuitive. Any number that is more negative than another number will always be smaller. Now consider the number line above. Think of it as a thermometer. When it is 10 degrees below 0, it is really cold outside. When it is 40 degrees below 0, it is really, really, really cold outside. Another way to express this is -10 is greater than -40, or -40 is less than -10. When the less than and greater than signs are used, the expression is called an inequality. Absolute value on the number line is calculated as the distance the point is from 0. For example, the distance from 0 to 4 is 4. The distance from -4 to 0 is also 4. Each is the same distance from 0. Each has an absolute value of 4. Let's try a few problems. The first problem, multiply multi-digit decimals using the procedures you learned in this lesson. 72.147 times 457.23 equals what? How many digits to the right of the decimal point will be in the result of 31.019 times 657.9? So let's take a look at the first part of that question. You can take out a pencil and paper and try your hand at it, but the answer is 32,987.77281. Notice that there are 5 digits to the right of the decimal point. There are 3 digits to the right of the decimal point in 72.147 and 2 digits to the right of the decimal point in 457.23. For the second part, there are 4 digits to the right of the decimal point in the result of 31.019 times 657.9. I'm sure you must know now why. Let's try problem 2. What is the greatest common factor of 72 and 32? What is the least common multiple of 6 and 9? So looking at the first part of this question, what is the greatest common factor of 72 and 32? Well, we know from our multiplication tables that 8 times 9 equals 72, and 8 times 4 equals 32. So I am guessing that 8 is the greatest common factor. You need to list out all the factors of 72 and all the factors of 32 and find the overlapping factors. Let's look at the second part. What is the least common multiple of 6 and 9? Well, we know from multiplication tables that the multiples of 6 are 6, 12, 18, 24. Multiples of 9 are 9, 18. Oh, look, there we have a common multiple. So 18 is a multiple of 6, 18 is a multiple of 9. So the least common multiple of 6 and 9 is 18. Let's try problem 3. The graphic to the right illustrates x is greater than negative 2 and less than 4. Look at the number line. The pink line with open circles at each end illustrates an inequality. If the circles were filled in, that would be an equality, equal to. So if x must be integers between the values of negative 2 and 4, what are the values of x? So we can see just by looking at the number line, negative 1, 0, 1, 2, and 3. So what did you learn in this lesson? Dividing fractions, multiplying multi-digit numbers, dividing multi-digit numbers, adding and subtracting multi-digit numbers. You also had fun with greatest common factor and least common multiple, and you took a look at the rational number line, coordinate axes, and ordered pairs. Finally, you took a look at absolute value on the number line. Now go take a look at the exam for this module, the number system, and best of luck to you.